All right, we're going to talk graphing proportions. So, one thing about proportional relationships is that they can be represented using graphs. So we can represent them using graphs, and we can use the coordinate plane for this. We will take a look at a couple examples down below. There's something very specific about the graphs that we need to know, and we'll talk about that. But one of the things that we want to do to help us set this up is to create ratio tables to gather the information needed to create a graph. One too many things on IE, apologize for that. Okay, so we can create ratio tables to help us gather the information. What that does for us, what that's helpful for, is that helps us to figure out kind of our values, the x and y values that would be on a table or on a graph. So, a graph is proportional when a straight line can be drawn through all the points. So when you can draw a straight line through all the points, all the ordered pairs, then it's proportional. Okay? Another thing about it, the line also needs to pass through 0, 0, the origin, to be a proportion. If it doesn't, it's not a proportion. So let's take a look at an example of a proportion together. All right, the 6th grade is going on a field trip. The school system requires 5 chaperones for every 75 students. If there are 120 students going on the field trip, how many chaperones will they need? So taking a look at this, we already have it in a ratio table for us. Chaperones, you see 5, 1, 2, 4, 8. Students, 75, 15, 15, 30, 60, and 120. Now what that means for us is this. This information goes together, this goes together, that goes together, that goes together, and that goes together. So what that allows us to take a look at with all of this is, I know that the 5 and the 75 relate to each other. I know that the 1 and the 15 relate to each other. And what that does, that tells us if I'm going to take this and turn it into a graph, this whole idea becomes what's over there. We need to know the x and the y value. So the nice thing about this graph, if you take a look down there and right there, if you can see it on your paper, it tells us number of chaperones on bottom, number of students on top. So chaperones is our x value, students is our y value. So as we plug this in for this one right here, okay, when x is 5, your y value is 75. Okay, when x is 1, y value is 15, and so on and so forth. What that becomes over here is, there's that point of 1 and 15. Here's that point of 5 and 75. What I want to draw your attention to is this. If you take a look at each of these points, that straight line goes through each of those points. Okay, that's one of the criteria we have, is a straight line can be drawn through it. The other criteria we have, and that's what you see right there, okay, straight line can be drawn through it. Another criteria we have is that line passes through the origin. So those two things make this a proportion. Straight line can be drawn through all the points, and it passes through the origin. Now you're saying, okay, why does it pass through the origin? Well, think about it. It requires 5 chaperones for every 75 students. If there are 0 students going on the field trip, how many chaperones are needed? Well, that answer is 0. If no one's going on the field trip, you don't need any chaperones. So that's where that 0, 0 comes from. All right, here's an example of a non-proportional relationship, and you see that by the box there. But taking a look at this. Okay, our first hint for all of this is when we said it has to pass through the origin. Well, if you take a look at the first thing that we have there, It does not pass through the origin. Okay, and the reason is when time is 0, our distance is 1. Okay, and it doesn't really matter what distance or time, the parameters of that is, but as you can see by what we have here and here, okay, time is my x value, distance is my y value. Okay, so the first clue that right away tells us not a proportion is when time is 0, distance is not also 0. That's our first problem that we have. Okay, the second problem that we have is if I take a look at this line, and if I follow that line all the way through, okay, I've got that point, this point, and that point are not on that straight line. Okay, they're close, but they're not quite there. The only one that works and is on that line is the very last point that we have there, 8, 11. Every other point is not on the line. So, because not all the points connect with a straight line, and the fact that it does not pass through 0, 0 is not a proportion. You could have something that starts at 0, 0, but if all of the points are not on there, like we see with this one and that one, if those points are not on there, it automatically is not a proportion. Okay, it has to meet the criteria, going back up. It has to meet the criteria that we see here, where all of those points are on that line, and it passes through 0, 0. So if it meets the criteria, it's a proportion, which we see right there. And if it does not meet that criteria, it is not a proportion. All right, tomorrow we are going to work on taking a look at all of this stuff. We will look at some more examples. We will also create some more examples as well. Come to class right tomorrow to practice this stuff, and I will see you then.